Welcome back. We're going to try to finish the other three questions for the 2024 FRQ that we didn't get a chance to do last time. We are dealing with the AB questions here, so let me go ahead and label that. Questions 1, 3, and 4 for the AB FRQ packet. Those are in a separate video since they are recycled and they come up in the BC FRQs as well. That's kind of nice. Okay, question number 2. The particle moves along the x-axis and the velocity is given by v of t. There is one time in the interval from 0 to 2 where the particle is not moving. Okay. Before that time, is the particle moving to the right or to the left? Okay. Remember, we do have a calculator for this section, right? So, A. We are going to go ahead and graph v of t. Now, the graph approximately looks something like this. Now it says there is going to be one time from 0 to 2 where the particle is at rest. So the particle is at rest whenever the velocity is equal to 0. So I can see one point right here. I can see another one right here. Go ahead and find those with your calculator by doing second trace 0. So the particle seems to be at rest at 1.4256. And it has to be before 2. Okay? So that's this one right here. Now, I'm going to just call it 1.4. Before 1.4, the velocity is positive. After 1.4, but before 2, the velocity is negative. So, this means the particle... Oh, no. The question says, is the particle moving to the right or to the left before the critical point, before the particle is at rest? So, the particle is moving to the right on the interval from 0 to 1.4256 because the velocity is positive. Okay. B. Okay. I'm not gonna be scrolling up and down because I don't want to mess with my zoom window. Then it gets all glitchy. But it says find the acceleration of the particle at 1.5. Is the speed of the particle increasing or decreasing? Well, since we're given velocity, all you gotta do really is find the acceleration, right? You can show a couple of different things. You can say v prime of 1. Oh, it should be 1.5. Huh? V prime of 1.5 equals negative 0.077. Or you can say the acceleration at 1.5. Or you can say the dt at t is equal to 1.5 of velocity is negative 0.07. Any of the three notations is valid. Oh, and you know what? I'm looking at my notes a little bit wrong. It is negative, but it's actually negative 1. Okay. And we're also supposed to go find the velocity. The velocity at 1.5 is negative 0.077. Yeah, I was mixing up my notes right here. Okay, so we already answered the first question, right? The acceleration at 1.5 is negative 1. Okay, for part B, is the speed of the particle increasing or decreasing? For that, we have to find the velocity. And now that we have the velocity, we can make our conclusion. Since the acceleration of the particle at 1.5 is negative, and the velocity at 1.5 is negative, the speed of the particle is increasing. So as long as velocity and acceleration have the same sign, the speed's going to be increasing. If they have opposite signs, the speed's going to be decreasing. Oh, you know what? I'll say at t is equal to 1.5. Okay. C. The position of the particle the position of the particle at time t is x of t, and the position at 1 is -3. Okay, here, I'll write it right here so you can see it. Find the position of the particle at 4. Okay, because we're given an initial condition and we want to find a position like at a later time, we're going to use the formula f of x equals the integral from a to x of f prime of t dt plus f of a. Now, we are using different functions here, so I'm going to change them. So technically, my position function is x. X of 4 equals the integral from 1 to 4 of the velocity v of t dt plus the initial condition. This setup is enough for you to show your work. Go ahead and plug it to the calculator. And we get -2.803. That's the position of the particle at 4. One more. D. Find the total distance traveled from 1 to 4. Okay. Well, total distance equals the integral from A to B of the absolute value of velocity dt. So in this case, we're going to be integrating 1 to 4 of the absolute value of the velocity. Careful when you plug it in, right? We don't want to make any mistakes because of the calculator. This is the total distance traveled. Okay. So that covers question 2. Now we have to move on and jump all the way to question number 5. Here we go. This is why I didn't want to zoom out. There we go. Oh, again. Okay, so now we have a curve defined by an equation and we have the derivative. There is a point on the curve near 2, 4 with the x-coordinate of 3. Use the tangent line at the point 2, 4 to approximate the coordinate where x is equal to 3. Okay. A. In order for me to make the tangent line, I'm going to need slope and I'm going to need a point. The slope is dy dx equals -2x. But see, I'm already given the point, right? The point that we're going to be using is 2, 4. And since my differential equation is -2x, I'm going to go ahead and plug in my numbers already. 3 plus 4 times 4 dy dx equals -4 over 19. Okay. Now I can go ahead and make my tangent line. Y equals m, x minus x1 plus y1, y equals -4 over 19, x minus 2 plus 4. And now we're going to go ahead and use it to approximate the y value at x equals 3. To be able to combine this, I'm going to get a common denominator. A common denominator of 19. And 4 times 19, well, 4 times 20 is 80. So 76. Which gives us 72 over 19. Okay. B. Come on, zoom in. Oh my God. I think I had to find a better program for these videos. Is the horizontal line y equals 1 tangent to the curve? A horizontal line needs to have a slope that is equal to 0. And they're saying, is the horizontal line y equals 1 a tangent to the curve? Well, let's see real quick. Well, the way I'm thinking about this is that since my derivative has to be 0, here, let's go ahead and erase this. That means that negative 2x divided by 3 plus 4y should be equal to 0. And if you solve this equation, we're going to multiply both sides by the denominator, which is still going to be 0. And that gives us a coordinate of x equals 0. Now with this, I can go back to my original equation, which is x squared plus 3y plus 2y squared, make it equal to 48. And I can plug in my 0. All right. Oh, you know what? I'm going to be able to solve this, but I'm going to have to use the quadratic formula. And I think that's going to be a little more difficult. Oh, no. Actually, no. I can actually plug in the 1. 3 times 1 plus 2 times 1 squared should equal to 48. And that's going to be 3 plus 2 is equal to 48. 5 equals to 48. And because this is not true, then we can say no. Y equals 1 is not tangent to the curve. Okay. Let me take a look at the question real quick before I move on and see if there's a second way I could have done this. Yeah, you know what? Right now, this seems to be the most efficient way. So we're going to go ahead and jump to C. The curve intersects the positive x-axis at the point radical 48, comma 0. Is the line tangent to the curve at this point vertical? Well, a vertical line has an undefined slope. So my dy dx that I was given originally, which is negative 2x divided by 3 plus 4y, that should have a denominator of 0. So does it? Well, let's find out. Dy dx equals negative 2 times the square root of 48 divided by 3 plus 4 times 0. Dy dx equals negative 2 radical 48 divided by 3. And there you have it. Since The denominator is not equal to 0. The tangent line is now vertical. All right. Part D. Okay. The particle is moving along another curve defined by a different equation. At the instant the particle is at 4, 2, the y-coordinate of the particle's position is decreasing at a rate of 2 units per second. That sounds important. At the point 4, 2, the y-coordinates of the particle's position, so in other words, dy dt, is decreasing at a rate of 2 units per second. At that instant, what is the rate of change of the x-coordinate? So dx dt. That's what we're looking for with respect to time. Okay. And here's the new equation. It's y to the power of 3 plus 2xy is equal to 24. Let's go ahead and find our derivative with respect to time. 3y squared times y prime plus 2. Let's do a little bit of product rule. The first times the derivative of the second plus the second times the derivative of the first is equal to 0. Now, let's go ahead and plug in the conditions that we were given. The y value was given to us, and that's 2. Y prime is also given to us. That's negative 2. Plus 2 times x, which is 4, times negative 2, plus y. Y is 2, and we're looking for x prime. So this right here is going to be negative 24 plus 2 times negative 8 plus 2x prime. That's going to be negative 16 plus 4x prime equals 24. If I add the 16, we're going to get 40. And then we're going to divide by 4, which is 10. And finally take our derivative. The derivative is going to be... Oh, whoa. No, I made a mistake here. It's not x squared. It's just x prime. Okay. Yeah, there we go. I almost made a mistake here. So that's going to be the rate of change of the x coordinate, which is going to be units per second. We have one last question to go, but my time is going to run out, so I don't think I should start it. I don't want to leave it halfway. So I'll see you guys next time for question number 6.